Thank you, everybody, for joining us. I am so grateful you took the time out of your evening to do this, and I am more than ready to turn this over after some technical difficulties to our environmental science co-author of our AP book, Rick Relyea. Rick, I will let you take over the screen and share your screen, and I've got some folks that are trying to connect, and so I will mute myself and help them.
Okay. Thank you, Jamie. Thank you very much. And thank you to everyone. Please let me know if you have any trouble hearing anything I say. And I think we traditionally give the webinar and then take whatever questions you might have at the end of the webinar. So on behalf of Andy Friedland and myself, we're delighted to offer another webinar. We sincerely love to talk to teachers who are teaching AP courses, and I know today we have a wide range of folks who, some who have used our book, some who have not used our book, used other books, some folks who haven't even started or just starting this year teaching environmental science. So it's a wide range of people. So in my comments today, I kept that in mind, that there are people who know a great deal about things like global warming, and maybe I'll teach you a few new things, a few new stories that you can share with your students. And for those of you who haven't, maybe I'll be able to share a lot of new information on global warming. And of course, that's relevant because of the documentation of 2016 as one of our warmest years yet on record. So what I thought I would do is, if you don't know me or haven't met me before, give you a little background on me, and then talk about the topic of tonight and talk about global warming. So with that sort of quick introduction, I think we can get started on this. That's me, and I'm a professor at Rensselaer Polytechnic Institute, better known as RPI. If you don't know, RPI is a big engineering school up here in New York State, near the Capital District, near Albany, New York. So I'm a researcher. I'm an instructor of environmental and ecological kinds of courses, in addition to the AP Environmental Science book for high schools. Andy and I have also authored an environmental science textbook for colleges. And Bob Ricklitz and I have authored the 7th edition of The Economy of Nature, which is an ecology college textbook. So lots of interest in everything from the research of the science to the teaching of the science in a wide range of different topics. So just a little bit about me and let you know where I'm coming from. Grew up in New York State, went to the SUNY State University, what we call the Forestry School at Syracuse. And I spent my time there up in the Adirondacks, close to where I'm talking to you now, studying all kinds of different birds, ducks, grouse, etc. That was my undergraduate time. From there, I moved on to Texas Tech down in Lubbock, Texas. And there I lived in the desert and studying mule deer and learning all about that kind of ecosystem. And for my PhD, went up to Michigan, where I specialized in studying aquatic ecosystems, particularly swamps and other wetlands. And that's me in the straw hat with a very different looking uniform, and doing that kind of work up there. So try to get some training in lots of different ecosystems and lots of different kinds of questions. From there, I went to the University of Pittsburgh, and I was at Pittsburgh for about 15 years. And there we did all kinds of work in aquatic systems, particularly in looking at the impacts of pesticides. And with the impacts of pesticides, we've studied that and diseases and contaminants of all sorts, and lots of interesting studies over the years questioning EPA's pesticide risk assessment scheme, looking at amphibian diseases that exist in wetlands, and most recently, a couple months ago, having a new discovery of road salt and how road salt causes frogs to change their sex, which is really surprising and disturbing at the same time. So lots of different kinds of work. This is 2 years ago, my research group. And I show you this to show you the variety of folks, from undergraduate to graduate folks who are working here. But also the second to last person on the left-hand side of your screen is one of our high school teachers. And we frequently have high school teachers that work in our lab. They spend the summer working in our lab and publish papers with us. So have a long time been dedicated to helping high schools and the teachers and the students. In fact, here's an example one of our local newspapers talking about the work we do with a local high school teacher and his students, trying to get students really discovering new things, developing hypotheses, setting up experiments, etc. Also, we don't just talk about being for the environment. We try to be a proponent of it. This is the house. This is a house we found a couple years ago here when we moved to New York about 3 years ago. This is a passive solar house and also active solar.
Muted.
See the solar panels on the roof. We try to sort of walk the walk and not just talk about it.
Muted.
The new research project up here in New York is on Lake George. And this is a project that we call the smartest lake in the world. This is a project that I direct with IBM and a local conservation group. You can learn more in that link. But we're really trying to understand what's happening to lakes around the world by studying the heck out of this one lake with advanced sensors. And there you see in science they talk about making the smartest lake in the world. And it's really about understanding a lake and being able to understand it with advanced monitoring, advanced experiments, and then modeling to figure out what are the human impacts on this lake, which are the same as lakes around the world. Things like too many nutrients, too many pollutants, invasive species, all of those things. So that's really what I'm all about in terms of doing research and focusing on human impacts on the environment. And all of that work helps inform the environmental science textbook, the AP textbook that Andy and I write. And Andy comes from the same sort of background of being a researcher who understands a lot of the major global concepts that we write about in the book. So together we cover quite a broad number of different areas. So that's the background of me, but I also, of course, wanted to move to the causes and consequences of global warming. And I think what's helpful in doing that, because we have a really wide range of folks on this call, is to think about, let's get on the same background, make sure everyone's sort of on the same page. Think about what are the consequences of global warming that we already can see, that we already know exist, we already have the data for, and then think about a little distinct from that, what are the things that we predict will happen that maybe we don't have the data for yet, but maybe computer models tell us are likely to happen, but we can't for sure say that those are happening today. And then a little bit on the policy, on the international agreements that are out there in terms of how that affects issues related to global warming. So that's the roadmap for tonight. It'll be about 20 minutes. We'll go through the roadmap, and then we'll have time for questions. So with that, we'll go to the background. And as most of you can appreciate, the words global change, global climate change, and global warming are thrown around a lot. We always like to get people on the same page that global change is a whole wide range of things. It can be contaminants, it can be invasive species, all sorts of things. One part of that is global climate change. And one part of global climate change is global warming specifically. And that's what we want to talk about, global warming, what it's doing to the world. And of course, these are all interrelated. But we really want to think about tonight about global warming. And we want to think about the greenhouse effect. And most of you know something about the greenhouse effect. And what I like to emphasize with my students is, the greenhouse effect is a very natural thing. It's been around for millennia. It's the reason that we're not freezing right now. The greenhouse effect, forget about the human impacts on it, the natural greenhouse effect keeps the Earth about 57 degrees warmer on average. So, this is where the visible and the UV light goes down through the atmosphere, hits the ground, re-radiates infrared light. That excites the greenhouse gases, and they re-radiate heat. Some of it goes back to Earth, some of it goes out in the atmosphere, and it's a really tiny fraction, of course, of the atmosphere. Most of it's nitrogen and oxygen, but those greenhouse gases, this tiny little fraction of the atmosphere, is what keeps the planet a whole lot warmer than it would be otherwise. And of course, the issue is we've made a bit more of that than is naturally available. You probably know this very well. The major greenhouse gases, things like water vapor, carbon dioxide, and then the other three, methane, nitrous oxide, and chlorofluorocarbons. Those three are in really tiny amounts, but their potential for global warming is really much, much higher than the carbon dioxide in terms of how much they can re-radiate heat and how long they stay in the atmosphere. They stay in the atmosphere much, much longer than things like water vapor and typically carbon dioxide, decades or centuries. That's why we worry about these things. We certainly worry about carbon dioxide as well. I always like to look far back into the future. When people say, hasn't global change been happening for a long time? It certainly has. Here's carbon dioxide from the researchers. This is from NASA, and all of these pictures are all publicly available. You can use them. We'll make these slides available. But you can also go to the websites and find them for yourself. Going back 400,000 years, you can see CO2 quite naturally fluctuates. We have periods where there's a lot and periods where there's not. The striking part, of course, is on the right-hand side, is after about 1950, it just shoots straight up on a 400,000-year scale. We can zoom in a little bit and look at a 10,000-year scale. Same kind of story, whether you're looking at carbon dioxide, or you're looking at methane, or you're looking at nitrous oxide. It really shoots up in the last 1 to 200 years. And this is really showing human impacts on these different gases. You can zoom in even more for carbon dioxide and look at the great data coming out of Hawaii starting in 1958. So this is about 60 years, right up through this past month. There's the website on the bottom corner. You can look at this anytime you want, get an updated figure for your students. And certainly there's no sign of it slowing down. In fact, it's slightly accelerating in terms of the amount of CO2 that's in the atmosphere. Again, this is measured out in Hawaii, one of the longest sets of data that we have on CO2 changing as a direct measurement. All of these greenhouse gases come from all of the different activities we have, from agriculture to landfills to factories. And in fact, in our book, you can see a breakdown. If you want to know where methane comes from, you see it comes from mostly landfills, livestock, and combusting fossil fuels. Nitrous oxide, most of it's coming from agriculture. Some of it from some other activities of people. And CO2 is almost entirely from combustion, whether it's for houses, for transportation, to generate electricity. So we have a good sense of where these come from. We also have a good sense of who produces them. And, the most developed countries are producing some of the most carbon dioxide. This is the millions of metric tons, and you see that China and the U.S. are big producers. One of the things that we also like to tell our students, though, is think about per capita, who's the most producer. What are the carbon footprint per person? And it really changes. And because China, of course, has so many people, the U.S. and Australia and Saudi Arabia and Canada are really the biggest producers per capita, and China drops way down in terms of its per capita production of CO2. So an interesting contrast there that students can enjoy talking about and thinking about, who's responsible for CO2, whether it's a total or a per capita kind of an issue. So that's the background. Most of you know a lot of that background. Maybe some of you are helped by a bit of that background. I think what's more interesting to people are the consequences of all of those greenhouse gases going up.